this outer product will increase the rank. The inner product will decrease and outer product will increase the rank of tensor. How? If you have a two tensors, psi, alpha, beta, gamma, sigma, that move toward the A, B, C, and D. And phi, theta, phi. If I say that these are moves towards, this is the outer product. In inner product, may in contraction, one will be one or two or three must be a same, and that must be a contracting. Okay, but these now we are discussing about if the all are different. Okay, then what will be happen? A, B, C, D, X, Y, C, alpha, beta, sigma, one minute. Alpha, beta, gamma, sigma, okay, theta, phi, and tau. Yes. Okay. Okay. So that is this straightforwardly. If we observe these transformation law, okay, when we have applied, this is the transformation law of if the if I say that this is the, if I say this is a resultant, and then they will be A, B, C, X, Y, D, Z. So these are the, these products will be increasing. No, top. Okay, so these will be increased, the outer product will increase the rank of the tensor. Okay. Firstly, you write it here, okay, just as we have done last time, okay, and this is transformation law of this, and this must be right here, okay, and then we will take common answer, okay, then that will be proved there, okay. Same rank tensor means if the indices are the same and rank is same, then they will be that will be suitable for addition or subtraction. Okay, mean if you have two tensors, for example, psi of alpha, beta, gamma, sigma that is transforming into psi bar A, B, C, D, phi alpha, beta, gamma, sigma. If the indices are same, okay, they may easily add or subtract. Okay. Sigma, this is the as I already explained. The same transformation law. Okay, because they have a same indices, they must have the same transformation law. Okay, even if these are indices are not same, if the only the rank is same. For example, if I say that these are not the same, okay. If I say that this is alpha, beta, gamma, and this is uh, capital X, Y, Z, and uh, W for them. Okay, this is the X, Y, Z, W for them. Okay, it is converting in X, Y, small w. But and whatever that are indices. Okay, if we are adding these, then the transformation law will be different. I mean, they will be transformed in such a way, but indices will be a different. Okay. Yes. Okay. May we add? Are these are comfortable to add or not? The question is this. One minute. Let's check. Okay, phi is equal to x, y, z. Yes, and this is sigma Okay. See, this was X, Y, Z, and capital. Yes, and X, Y, Z, W. Yes, and here will be a prime. Yes, and X, capital Y, capital Z, and okay. So these are they are a different. Now we will check. Is it possible to add these? Are these two different transformations are uh, comfort to add or not in suitable? My question is why indices must be same. It is not important. Uh, Order must be same. With a gamma plus minus inner product में or not in outer product. Because they are not their non-indices are same. Construction always reduce the rank of tensor, but outer product will always increase. Uh, Actually, the multi-rank tensor are the outer product of different rank tensor. We will do it. Okay, that is the next theorem. Okay, yes. Okay, so if we add our what are the results? That was these are the A, B, C, D, and here is phi X, Y, Z, small omega that are the resultant. Let's check. May we add are these 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Yes. Okay. So that was psi alpha, beta, gamma, and sigma. Okay. Plus minus 4, 5. That was capital X, capital Y, capital Z, and capital W. Yes. This was A, B, C, D with more. They may be, we are checking both simultaneously, addition and subtraction. Actually, addition and subtraction is the same. Division and multiplication. Actually, there are two bodies operation, only addition and multiplication. Division is inverse multiplication, and subtraction is additive inverse or negative with negative sign that will be added. Okay, so that actually both are the same. नॉट इन कॉमन मतलब ऐसा ना हो कि आपने मैंने आपको किसी को पैसे देने तो आपने या मैंने आपको ऐड करके दे रहा हूँ आप मुझे नहीं मैं आपको सब्ट्रैक्ट करके दूंगा और आप मुझे ऐड करके दें So the mean if operation are the same, they are not same, they are not equal. I'm not claiming they are equal. They are different, but the operation. Yes. The result are not same. If result are same, then I think they must be equal. The result are not same. Usually we check. I think even at this matter I am not right, because when we multiply 0 with any number, when that is possible, that inverse is not possible. But actually that is also defined as a multiplication, but the multiplication of the inverse number. So it doesn't mean that the result will be same, result will be different, but operation are related. Operation are also not same, but means they have they are related to each other. Okay. Operation same cannot be not. Okay. So yes, alpha, beta, gamma. Sorry, this will be alpha, beta, gamma, and sigma. Yes. Okay. Here is this is x, y, z, and this is small z. Yes. X, y, z, and this is omega. Oh, sorry, small w. And here is capital X, capital Y, capital Z, and W. Now it's okay. Okay, now it's looking that is not comfortable to add, but from the laws of the mean indices and free indices, if you are interested to replace free indices, that must be replaced in each term, and if you are interested to dummy indices, then they may be replaced any whenever you are interested in any term. Okay, freely, you don't need to be converted. So here x, y, z are a dummy indices. I am interested to take a common, so that's why I'm interested to replace it the alpha, beta, gamma. Okay, so no, all are not dummy indices. Only green are dummy indices. Blue are a free indices, and greens are why I have used the different markers or different color markers, because blue will be representing the free indices and green will be representing the dummy indices. So they may be. It's up to you if you are interested to replace these indices or these indices. That's up to you. Okay. Let's suppose if I am interested to these dummy indices. Okay. So since x, y, z, and w with the green color are not only green, they are black too. Okay, so I are dummy. Because at left hand side I have used the green x, y. If I write it in this green x, y, z, and now it is okay. Sorry. Okay, now x, y, z with the green color are dummy. Now this statement is true because now this is green. Okay. So we may replace it with alpha, beta, gamma, and sigma. Okay. I'm only changing the color alpha, beta, gamma. Sorry, alpha, beta, gamma, because to ensure that all green numbers are dummy, so that no one may have objection why you are saying the all green colors are this is green color are a dummy, but because at that time there are some indices which are not. Okay, so all greens are a dummy here. Okay, yes. So these may be replaced with the alpha, beta, gamma. So uh, these are the same. I'm not changing anything at left side. I'm not changing anything at left side, but uh, on the on not first plus minus sigma alpha beta gamma sigma, and that's and sigma. This is and this is alpha beta uh, gamma and sigma. Okay. Okay. So may we write on this way? Yes. So even noise problem is here because they are different. Yes. But these are the at left and right, they are the same. If you are interested to replace these are the free indices, then you have to replace all free indices. If you are interested to replace and free indices, then you have to replace it in each term as a resultant, okay, as well as in resultant. So if I replace here, the main indices will be replaced only in the term, and resultant will be not changed. But in free indices, you may replace the okay. So similarly, yes, you may. मैंने तो समझाने के लिए मुझे पता है क्योंकि अभी आप नहीं आपने लेना डिफरेंस बिकॉज देन मेरा कहने का मतलब है कि ये दो स्टेप मैं जो 11 लेना चाह रहा हूँ आप कंबाइन भी कर सकते थे कि यहीं लिखते हैं ये डमी इंडिसेस है ये फ्री इंडिसेस है दे मे बी कंबाइन यू हैव टू डू ऑल स्टेप बट यू मे कंबाइन 1 and 2 स्टेप बट ये मैंने क्यों किया ये इस वजह से कि मुझे पता है यार मैं अभी करता हूँ तो अभी आपको समझ ना आती लेकिन इन एग्जाम यू मे डू इट बिकॉज उस वक्त आप मैच्योर हो चुके होंगे ठीक है not really. Okay, now x, y, Z, and omega are free indices, and we may replace it with, yes, yes, क्या okay, why here is the alpha beta gamma. These some are multiplied, okay. So these are the dummy that will be replacing each term. Dummy, this is mean I have already explained you in the last lecture. If you have alpha beta, okay, alpha beta gamma, like simple, okay, alpha x alpha, they will be x beta x beta. Mean the dummy indices mean two indices. They may be they will replace with multiple factor too. Okay, got it? Means if alpha is replacing with the beta, then both will be replaced, not one. So that's why. Okay, got it? This is changing, this is. Alpha is changing as here. I'm saying capital X, capital Y, capital Z, and capital W. All are changing. Alpha X is replacing with the alpha, Y is, I must write, yes, that's my mistake, and must write respectively. Thanks for correction. Means X is replacing with the alpha here, Y is replacing with the beta, Z is replacing with the, but in all places where it is mentioned. Okay, got it? Now it's simple. Okay, I think now there's. Yes, that is Guru. That is a very important, because if you are not replaced, then how you will take on the common. Okay. Similarly, x, y, z, and omega are free indices, and we may replace it with the yes. A, 1 minute. These are phi, not phi. Zero कैसे है सर? 1 minute please. एक मिनट. Small x will be replaced with the A, yes. B, C, and D again respectively. ये कोई प्रॉब्लम है? Respectively means x will be replaced with the A, y will be replaced with the B, z will be replaced with the. Yes. Okay. So now again. Yes. Yes. This is there is no change on these terms. Okay. They will be remain the same. But these are the with the blue indices. Okay, X, Y, Z, and A, B, C, D, are. Okay. Okay. And because these are A, B, C, D are free indices, must apply resultant as well as in each term. And that is very important. Okay. The mean indices will be apply only the sum, but free indices must be applied on the both side of the. It must be applied on the resultant as well as there is a condition on the free indices. Okay, so free indices will be applied on both. Okay, so yes, plus minus. Yes, you are right. So it means it must be replaced here. Okay, so it must be applied at the right hand side too, or left hand side too. That is, yes, that is A, B, C, and D. Okay. So now you may take common. Both are the same in the class. So I think I must write. There is no summation or addition term when you take a common. Okay. So this will be the same for both. The sums of alpha, beta, gamma, sigma, plus minus, that will be here. No, yes, yes. These are, we are taking the common. Okay. This sums will be okay. There is no summation and subtraction. I know if some students will be, if I have not mentioned it, then some student may write in a paper that there is a summation in mind. There is a no such. That is the common term. Okay. So that's alpha. That is A, B, C, D. Alpha, beta, gamma, and sigma. And these are the results. Okay. And we say that from these transformation laws, we easily observe if I say this is a resultant R prime and this is a resultant R, then this transformation will be satisfying all the transformation laws. Okay. So if I say that this is any resultant of R prime, okay, that is A, B, C, and D, that is the same. Okay, and this is the alpha, beta, gamma एंड सिग्मा। आई थिंक मुझे एक्सप्लेन करने की जरूरत नहीं है, आपको सिंपल नजर आ रहा है कि ये ट्रांसफॉर्मेशन आपने ट्रांसफॉर्मेशन लॉ की मदद से चेक करना। Okay, so from these you can easily observe that they are obeying the same transformation law. Yes, so that may be. So even if if two tensor of the same rank, then they will be they may be conferred for addition and subtraction in both cases. Got it? I think. And why? If you observe this transformation law, these are the result will be. मेरा ख्याल है वहां जगह कम है, दोबारा बता देता हूँ, दोबारा समझ लो। You have a psi plus minus phi, yes. Okay, a पता नहीं ऐसे कैसे लिख लेते हैं लोग, A B C, yes, D A B C and D, yes. Okay. Yes. 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 Now forget what is that. Okay. If we are adding these and it is replaced with the A, B, and C and D, okay, right hand side. Okay. And I use these transformation line and I write A, B, alpha, beta, gamma, sigma. If I say this is this and this is this, and applying the transformation law, इसको भूल जाओ, तो वो वही रिजल्ट देगा जो कि इस जैसे। मुझे पता है पेपर में आप लोग मोस्टली स्टूडेंट ऐसा नहीं करते, लेकिन एक्चुअली इसको समझने की तभी है कि आप खुद करके देखिए। अब इसके ट्रांसफॉर्मेशन लगाओ, इसके हिसाब से यू अप्लाई दिस ए, दिस इज बी, दिस इज सी एंड दिस इज डी, alpha is this are the same, are they same? So मतलब अगर ये डिफरेंट होता तो it means they are not the same and the result is different, okay, but they are, since they are same, एक्चुअली हमें अलग अलग करना चाहिए, हम टाइम बचा लेते हैं, ठीक है। What is the deal? This and this. Okay. ठीक है। क्लियर हो गया? ठीक है, दिस कलर लाइन इज सेम एज दिस, ओके, यानी दिस इज सेम, so it means true. Actually, you have to apply transformation law on this, okay? Then you will check that. You are saying that this is the resultant of this is the resultant of this. Now you have to check the transformation law after applying the transformation. यहाँ से भी कॉपी करना, असल तरीका ये है कि यहाँ से कॉपी नहीं करना, आपने इसको क्योंकि इस तरह लिख सकते हैं, इसको ऐसे रखो, इसको ऐसे लिखो, इसका ट्रांसफॉर्मेशन लॉ लगाओ और देखो अगर वो सेम है तो पेपर का ट्रिक तो यही है कि आप कॉपी कर लोगे, मुझे आई नो दैट, मतलब लेकिन समझने के लिए जरूरी है, ठीक है? पेपर के लिए आप इतना टाइम वेस्ट नहीं करोगे, आई नो दैट, ठीक है? ओके, योर क्वेश्चन इज गुड, ठीक है? एक्चुअली दिस आर ए बी इज दी ए बी सी डी प्लस माइनस 5 ए बी सी डी. Why I may write it in this form? क्यों लिख सकता हूँ why I? Because in the previous theorem, लिखें सारी बात लिखें. In previous theorem, what we have done, if the rank is same, if two different are adding, they will be comfort for addition, okay? They are comfort for addition. So this can be right in this way. We have already proved in the previous theorem. लिख सकते हैं? Yes, yes. Okay. So these are A, B, C, D, that may be right in this, and this will transform as okay, this is transforming from alpha, beta, gamma, sigma, okay, this transforming, okay, and this is ये भी इसी तरह, firstly actually this is also sum of psi alpha, beta, gamma, sigma plus minus alpha, beta, gamma. Due to this, because they are comfort to add, we have already explained that under transformation, the addition will be transformed. Reference, you have to mention the reference. What is the reference? Reference, you must mention each and every reference, previous theorem. Theorem, yes, you may write. They are comfort to add, okay, according to theorem. Okay. Yes. Now you may apply the transformation law if they are a comfort. So you may write A, B, C, and D. Yes, this was converting. According to this, A, and this was prime, A, B, C. Yes, alpha, beta, gamma, 6. Yes, ये हमने सिर्फ इस पे ट्रांसफॉर्मेशन, because we know that these are the this may be transformed this, and so that's why I have transformed, and we check. Okay. Now check, this is this comes from this. If I say this is equation, मैंने वो ब्लू और रेड पे आप वैसे ज्यादातर तो अच्छी बात ये है कि आप एक्स वाई के साथ में लिखें. This is, let's suppose this is equation x. This is equation y. Okay. Now comparing the x and y. नहीं सेम तो नहीं है. Comparing x and y, both have same transformation. Now, that's it. They are same too, because if you consider, if you put the value, they will be the same. So these transformation law for the transformation law for defining for this and transformation law defining for this, they are the same. So it means physically, actually I have already explained, the transformation law will tell that what are the nature. If the transformation, there is a single transformation law, then there will be a single rank tensor, they will be vectors. If they are a zero rank, then they will be a scalar, mean they will be magnitude type quantity, that will be the main invariant. If they are a 2, 3, 4, then that will be outer product of these different rank tensors. So since these are the same, and so they will be obey same property. Yes, now it's clear. Rank tensor are actually I'm interested to observe that actually what are the multi-rank tensors. We know that these are the transformation law. We know everything about the multi-rank tensors, but we are only aware about the single rank tensor. We have only proved that single rank tensor are actually represent the vectors. But what are the actually the multi-rank tensor? We have not explained it here up till yet. Okay, so multi-rank tensor are I think I have mentioned in my first lesson. Multi-rank tensor are actually the outer product of different. Multi-rank tensor are actually outer product of, why I am writing the single rank tensor? Because we know the physical significance of the single rank. We don't know about the physical significance of multi-rank tensor, but we know the multi-rank tensor are actually the outer product of single of single rank. This thing means different. Okay, they are not common. Okay, single rank tensor are actually the representing vectors. We know about that. Single rank tensor are actually vectors. Whenever you take a multi-rank tensor, actually they are not they are actually nothing else. They are the outer product different and different tensors. When you two rank tensors that are a matrix, that will become from the two single rank tensors. They will be outer product of two single rank tensors. Similarly, for example, let's suppose you have a 5 single rank tensors. Okay, let's suppose you have a f, alpha is going to fa. Okay, F beta is moving toward F B prime, F gamma is moving toward F C. Oh, sorry, some must be up, some must be a down. Alpha is going to A, B is going to beta, gamma is going to C prime. Some are conservation, some are, we know that the, what is, excuse me please, what is the covariant, we know that what is the covariant, what is the conservation. What is the covariant and what is the conservation, and we take the dot product. The original vector will be a conservation, and when the other partner will be a covariant, in that will be a complex conjugate of that. Okay, so other partner will be, okay, C alpha will be, so we are well aware about these are the vectors, these are also a vector, but these are the vectors which are itself vectors, and they are other are a projections, that is complex conjugate. Okay, so alpha beta gap. Okay. Why I'm using the same F? No, both are a vector. No. Conservation are a vector, and covariant are its other partner. Okay. Alpha F G H gamma C. Okay. F is transferred to F bar. Both are conserving. Both are vectors. This is in the old space, and that is the new space. I mean, if there is a rotation, after rotation, that is the final point, that is the initial point. Okay. This is the vector. This is also vector. These are the covariants. I mean, this is the covering part, covariant part. This is also this is conservation, and then these are the covariant. They are a different single rank tensor, and we are well aware about their physical significance and their transformation law. Because if they are, sometimes we confuse with that the indices represent the tensor or a vector. Usually people in Pakistan, and usually people in Pakistan consider that if there are indices, then that are the vectors. That is absolutely wrong concept, because sometimes indices may confuse you. Because indices, they may be a false indices, they are simple indices, but they are not obeying the transformation. Actually, transformation law will be tell about that that are vector or not. For example, in next lecture we will maybe in upcoming lecture we will study the flat matrix that will remain, that have a two indices, tensor indices, but they are invariant under the homogeneous Lorentz transformation. I mean, transformation law will be, they will be remain the invariant under transformation law. So they will become a zero rank tensor for the homogeneous Lorentz transformation. Even they have a two rank tensor. So two indices, not two rank tensor. Similarly, in particle physics, sometimes gamma mu has a four vector, but they are not a vector. They are not a vector. They are not a tensor. Up till they are multiplied with this psi and psi bar. and the indices must be same. This is by my research paper that these indices must be same. If the indices are different, then they are not a vector. Even then, okay. So indices are never ensure us that our tensor are not, but their transformation law will be ensured that these indices are true or not. If these are indices are false, then they will not a vector out. Okay. So transformation these law हम करेंगे आगे, ठीक है। ये हमारा ऐसा ऐसा भी मैथमेटिक्स हमारा ऐसा सब मेच्योर होगा। अभी हमें ट्रांसफॉर्मेशन लॉ को इतनी डिटेल में नहीं किया, ठीक है। आगे हम ऐसा ऐसा जब करेंगे तो हमें पता चलता जाएगा, ठीक है। क्लियर हो गया? Okay, so these are the transformation law. Okay, no, these are the f is transforming in this. These are the different singular and tensors. No, I have already explained that. Yes, they may transform into contravariant, and contravariant may be converted into the transform into covariant, and covariant may transform into contravariant. You are right, but abhi, you are not so mature how we will transform it. And in next upcoming lecture, I will teach you how the indices mean how you may convert convert contravariant into covariant and covariant into contravariant. For this, we will use the flat matrix. Okay, what is the flat matrix? I think अभी आप लोगों ने नहीं पढ़ा. That is the our next that is regarding next matrix. Okay, f alpha g beta. We are taking the outer product. ठीक है. Okay, h gamma. All indices are different, so these are. No, sorry. Alpha, beta, gamma, sigma. हमने राइट साइड लिखनी है ना. टा इज कन्वर्टिंग टू. ये आप अपनी मर्जी का भी लगा सकते हैं, मेरे लगाना जरूरी नहीं. इट्स अप टू यू. F A G B H C sigma D phi E. Okay. Now these are converting into, F is converting into alpha. So all are a single and tensors. So single transformation law will be applied on everything. FGH psi and phi. Okay, 1, 2, 3, 4. 1, 2, 3, 4. Okay. Yes. Okay. Yes. How you will apply it? Alpha, this is beta, gamma, sigma, alpha. Yes. अल्फा बीटा gamma सिग्मा था। यस राइट, मैंने समझा कुछ गलती हुई है। अच्छा ए बी सी यस ए बी सी डी ई यस okay, here will be alpha beta gamma sigma tau. Okay, yes, and these are multiplications when we take a common. I think you must mention this in this is I think आप उसे ऊपर से था ये yeah, these are the field C. Yeah, that is subscript, A subscript, A subscript, A subscript. These नहीं अच्छा ये गलती से सॉरी बच्चों ये आप ठीक थैंक्स फॉर दैट this is a multi-rank tensor. What is that? That is A B D C E prime. That is you will write these all transformation laws. If I say this is 1 and this is double line, और अगर मैं इसी के ट्रांसफॉर्मेशन लॉ को यहाँ अप्लाई करूँ तो we may easily check that double line is equal to single black line. Since they are the same, that means the result will be okay. अच्छा यहाँ भी करना है, ये लिखना है, पेपर में ऐसे ना लिख लेना। मैंने पेपर में बहुत से लोगों को देखा है, वो you have to apply in this. पेपर में नंबर काटते हैं, you have to apply in this, or you have to mention that these are the same. Okay. Okay. So that means these are the outer products are actually these ये जैसे पिछली दफा इन्होंने सजेस्ट किया था कि हम अपोजिट चलते तो ज्यादा काम था, तो हम इस दफा अपोजिट चले, मतलब move from the we have taken the single line tensor and move toward the resultant that are the multi-line. Means this multi-line tensor is actually the outer product of different single line tensors. Okay, so actually the multi-line tensor are the outer product of the different single line tensors. Okay, got it? So this is the way to transform different single line tensors. Okay. Okay, by taking an example of two-head tensor, verify that every tensor may write as combination of symmetric and skew-symmetric tensor. Okay. For example, if you have let's suppose you have alpha beta is converting into AB. Okay. इसकी भी जरूरत नहीं, psi alpha beta is two rank tensor. Okay. If I subtract or मैंने ये add and subtract कर दिया, there will be no change in thing, that will be the mainly same. Okay, one time add कर दिया, one time subtract कर दिया. Okay, this may write in this way. Yes. Okay. मैंने इसकी बजाय ये ऐड हो सकता था, the similar terms are added in subtraction, and I added two times. That's why. Okay. Okay, may I write in this? This is the let's suppose let's say these, as I have already explained, if the even indices are different, if the rank of tensor are different, they are converted to add. Okay. Yes. If I say that this is f, this is f, and I say this is alpha beta, I replace this plus this is let's suppose this is a, and this is also alpha. I may write alpha beta or beta alpha. Okay, these are the two types. Okay, so this file is combination of this, where S is 1/2 psi alpha beta plus psi beta alpha, and yes, no, I think there is no problem. Okay. आपको क्यों मल्टीप्लाई किया? Good question. If you have a 6 and if you are interested to write it 3 plus 3, how you will write? 6 को अगर आप लिखना चाहते हो, okay, one minute. If you have a 6, अगर मैं लिखना चाहता हूँ 6 plus 6 divided that, कितना लिखूंगा? मैं असल में उस फॉर्म में ना, जाहिर है ये हाफ के बराबर ही है, so because adding the same term, that's why I am dividing. Okay. Okay. And why I have divided it? Because I make up this combination. Why I am interested to make this combination? Now I will prove. Because आपको ये तो समझ आ गया ना, एक सेम चीज को ऐड करके दो से डिवाइड करते हैं तो वही चीज आती है. This is the, I think, simple mathematics, FSC mathematics, no, 6th class mathematics. X is equal to 2x multiplied by 2, x plus x divided by 2. This is okay. So that is very simple. Okay, and that's the reason this is equal to this. Oh no, this is not equal to this. Yes, this equal to this. Okay, the same. And then I have to take this combination. Why? Acha. It may easily prove S is symmetric and A is skew-symmetric. Now we have to verify this. Okay. Yes. F is yes. Beta alpha. Yes. Okay. What is the beta alpha? Yes, that will be from this symmetry, because you have changed the indices. Free indices will, because alpha beta free indices are, I replace all free indices in each term, and in resultant they will remain the same. That I have described in the previous lectures. Okay, I have replaced alpha with beta and beta with the alpha. रेफरेंस यूज जरूर करना है. रेफरेंस क्या है? अपने हर चीज की रीजन जरूर देनी है, ठीक है. विदाउट रीजन आपके मार्क्स जो है कट जाएंगे. रेफरेंस क्या है? वाई वी कैन से, वाई वी मे से, no, these are not dummy indices. These are there is no summation, no indices are repeating. These are free indices. Indices and must replace everywhere. Okay, if you are replacing alpha with beta, beta with alpha, it must be replaced everywhere, in left hand side and as well as the right side. In the dummy indices, they will be applied on a one side, but in free indices, they must apply on a every side. Okay, so S will be beta alpha yes, these are the vectors. Okay, and vectors obey the commutative law of addition. So free indices and it must be and it sorry, and it आएगा, these आएगा, and these वो अभी पता चल जाए. All we have already explained and proved that all tensors makes a vector space. Okay, and the multi-rank tensor are actually the outer product of vectors. Vectors are single rank tensors. Yes, and according to vector space, they must obey the law of commutative law of addition. They must make a abelian group under addition. So since these are making the abelian group under addition, you must write all these references, because reasons, that justification. आपने पेपर में आपने देखा होगा, everywhere in question they mention that you justify your answer, even if it is written on the your note. Your answer must be justified. Okay. So why this is true? Why? You have to answer why. That is very important. Okay. Yes. Why? Yes. under addition. Yes. So that's the reason. Okay. And what is this? From x, this is alpha beta. So alpha beta is beta alpha is alpha beta. If you replace the indices, mean if you change the order clockwise or anti-clockwise, there will be that will be not affect. So this will be the symmetric tensor. So actually this is symmetric. Okay. And if we consider A, now what is alpha beta A? We have to find, is this symmetric or not? We will prove that, we will verify that these are not symmetric, because A alpha beta is yes, that is 1/2 psi alpha beta minus psi beta alpha. I think we don't need to repeat everything again, because we have already explained each and everything. So we may write it exactly. Yes, and this is a geometry. These are the skew. Okay. So so every tensor alpha beta may write as combination of alpha beta plus combination of, they can be divided into two parts. One will be a symmetric and one will be a skew-symmetric. So every tensor may be divided into the two parts. And what is about the 3 and 4 and 5 range tensor? That is available in my next lecture. That is your assignment. You will prove that it's for 3 and 4. Okay, that is your assignment. Okay, for n rank tensor, that is available also. Okay? For n, I have proved that it for 2 rank tensors you will verify it for n 1, 2, 3, 4, generally n. Okay. Oh, sorry, that's why you are asking. Yes, skew symmetric. Yes, असल में वो yes you are right, but पहले ही सीधा कह देते. ठीक है, ठीक है, थैंक यू वेरी मच. ठीक है, हमेशन का मतलब ऐसे वो. ठीक है, क्लियर हो गया. Make abelian group under abelian. Okay. So एक मिनट. Lorentz transformation are flat space tensor Flat state means without gravity. If you are not involving gravity, then what will be happen? Okay.